We still got this 10% latent heat we've been throwing away. Maybe we can find a way to go ahead and let it rain in the boiler. Maybe we can build a boiler out of materials that handle that, and maybe we can go ahead and go condensing and pick up that extra dime we're throwing away. So what do we got now? Remember the 10%. If I'm at 88% efficiency non-condensing, and I add 10% back because I condensed it, I'm now able to push that thermal efficiency up to 94, 99%. That's a heck of an improvement. And now you begin to see where everybody's going that way. Can we really get to those 98, 99% numbers? We can if we pipe them right and run them right and design them right. That's what we want to talk about. You cannot get there if you don't make sure it rains in a bore, and then you want to make sure you maximize the efficiency of your investment. That's what we want to talk about. How do you get 98, 99%? And it doesn't matter whose condensing boiler this is. These are just fundamental principles and application of those to push that efficiency as high as you can. So we got to do that. We can also, by taking advantage of the latent heat, we can condense it, and we condense it, pick the 10 cent up. And then red is a fundamental little statement I want you to make. At full fire, we have this heat exchanger size there, this stainless steel heat exchanger, whatever the material may be, that we've got for condensing boiler. When we go to 25% fire, 25% natural gas, and we're going to match the air to 25% air, that heat exchanger didn't shrink. So we got a heat exchanger size, 100% fire, and then we're only going to put 25% fire on it. So naturally, as you modulate down, you pick up efficiency. You got the same heat exchanger size for 100%. You only put 25% through it, and you're matching the air and the gas to that. So modulating down, as you modulate down a condensing boiler, anybody's condensing boiler, the heat exchanger doesn't shrink, and your efficiencies start up. So one quick thing you need to learn out of this, that's how we start pushing towards that 99%, is by running them modulated down, not at full fire, but maybe at 50% fire is a place to look. Let's talk about that a little bit more as we go. So basically, looking at condensing boiler technology, we're seeing basically two types of technology being used. One is this pulse combustion process, and the other one is this old-fashioned gas burner fired process we've been used to. So these are the basic two ways of getting it done. So let's take a quick look at both. On the pulse combustion boiler, there is no burner. You got a spark plug, you got air and natural gas coming together, and you're sparking it like a little spark plug. Bang, bang, bang. And you're generating the heat out of this, and it works pretty good. You're bringing gas in it, and you've got electronic spark, and that's why they call them pulse condensing technology, because that's exactly what they're doing. It's like a big spark plug firing on and off, on and off, on and off. Now, a couple of side benefits of these things. They do work a little bit louder than others, than traditional gas-fired boilers with heat exchangers. So the vendors that make these most of the time will put a muffler on the insulation right up front to reduce that extra noise. And I guess the last comment would be I would not put one next to the principal's office. I'd be conscious of where I physically put them, knowing they're going to be a bit louder, and application-wise, just making sure you don't create a noise situation. They work. The comment's just meant to help you in an application standpoint, and that's the message given to you. Let's look at this burner technology a little bit. Let's call them second-generation condensing boilers in the USA. All of this technology came from Europe, as you'll see in just a minute. But this second generation, the vast majority of these condensing boilers are one heat exchanger. To begin with, they had a standard heat exchanger with a condensing heat exchanger, 2 steps. The vast majority of them today have gone to 1 step with one heat exchanger. These are smaller modules. Vast majority of them are stainless. The controls are much more simple than they used to be, and they really can be pants-laid together, and they're very reliable. We're there. For the condensing second generation boilers, we're there. First cost is coming down, highly competitive with non-condensing. Let's take a quick look so you understand the difference in the old-fashioned non-condensing boilers and how you ran them in efficiency, and the new ones. This is important from an application standpoint. You get this. So the light green there would be the old non-condensing boilers, and the top dark green would be the condensing boilers. And as you see, this is a plot of boiler capacity, boiler fire rate versus efficiency on the vertical left-hand axis. And you note that the old constant temperature boilers basically had the peak efficiency 100% fire. In this case, 71, 72%, which is probably pretty real. But look what happens as I reduce the fire rate on the old boilers. They start deteriorating around about 50%. The efficiency starts down. So at 20% fire, I'm down to 60, 10% down to 50. And this is fairly typical of the old boilers that did not have control of the air properly. Let's go to the top now to the condensing boilers. Condensing boilers, dark green. Remember that heat exchanger size doesn't shrink, and we're going to match gas and air together. So as I reduce the fire capacity on a condensing boiler, top green line, what do you see? You see the efficiency moving up at part load. All the way down, we're at about 10% fire. I'm up to 97, 98 points. I'm going to repeat this point to you many times in the next few minutes, so please don't misunderstand what I'm trying to do here. I'm trying to make sure you understand the fundamental application of condensing boilers would suggest to you to run multiple boilers versus one. The old boilers, we ran 100% fire. With a condensing boiler, you'd rather have 3 at 33% than 1 at 100. You'd rather have 2 at 50% fire than 1 at 100, because by going to 2 at 50 or 3 at 33%, you're going to have a much higher efficiency. 4 or 5 points you can pick up by simply staging your boilers properly and loading them properly. In the old days, we went 100% fire for falling over and on. That was the thing to do. Not anymore. So you got to change the way you think. You want to run a condensing boiler at part load if you can, because you're picking up efficiency. And I can now begin to push you up towards that 97, 98 points by doing what? Running them part load and making sure they condense. Now, also got to look a little bit at return water temperature. We're going to bring both of these pieces together. You're going to hear them a couple of times, so don't panic. But this is a plot of return boiler water to the boiler versus the efficiency of the boiler. And the dotted green line is roughly 130 for natural gas. It's roughly the dew point, roughly the condensing point. In other words, if you have a condensing boiler that you purchased and you said it was going to be 99% efficient, that's great. If you give it return water going to it of 140 degrees, it's not going to condense. It's not going to be anywhere near that efficiency. It's going to be in the 80s. You've got to get the return water cold enough to make it rain in your boiler. You want it to rain in your boiler. It's condensing. It's the best way to describe it. You want to make that water vapor rain back in there, and that's what you want to happen. But here's the piece a lot of people miss. Look at what happens as I go down below that 130 on the return water temperature to the boiler. At 120, at 100, see the red line? The lower the return water temperature, the higher the efficiency. Look at 60 degrees. I'm up to 97, 98% efficiency by lowering that return water temperature as cold as possible. So what are you getting out of this? The colder the return water, the higher the efficiency. Wow. 2 key things you've learned here, I hope. Modulate your boiler down for higher efficiency and give me colder water for high efficiency. If I get both of those things going on, I get the best of both worlds, and I can get you 97, 98, 99% efficiency that you're after. And you can control these most of the time in the way you design your plants. So what am I saying to you in a nutshell? The heck with your supply water temperature. I really can't say that, but that's the way I'm trying to get the message to you. The heck with it. I'm worried about return water. I want to make sure I'm below that 130. It's not going to condense at all. But I'd rather be colder. The colder I am on the return, the better off I am. Now you begin to see what is delta T. Maybe these pressure independent control valves where I can push the delta T up might be helpful. And that's where we're trying to take you to. Now let's bring both of these concepts together on one chart and just drive this point home. I said I was going to mention it to you 2 or 3 times. I'm going to put both pieces of what I just tried to teach you in one chart. I've got a plot of temperature across the bottom and efficiency in the vertical axis again. That solid red line is 100% fire, 100% input, 100% load on the board. The dotted red, not dotted, but the dashed red line is 50% input, 50% fire. We've modulated the boiler down to 50%. So let's look at what happens first of all, with a solid red line, is we reduce the return water temperature. See the magical line around about 130, it starts jumping up, that ballpark, because I've started to condense. But the colder I get the return water, the higher the efficiency of this particular boiler. I peak out where 93, 94% efficiency by lowering that return water temperature down to 70 degrees, 75, 80 degrees, as cold as I can get it. Got the message? But take the same boiler, and take it to 50% fire with this dashed red lines. What happens to that thermal efficiency now? Take a quick look. It goes way up. In other words, if I ran 2 boilers at 50% fire versus 1 boiler at 100% fire, I gained, 4 or 5 points of efficiency just by piping it that way. So you see the straight dashed lines below 130 jump up rapidly. They peak out at 97, 98 points. So if you ran 2 boilers in parallel at 50% fire versus 1, just that simple little control strategy is just that simple. On this particular boiler setup, you pick up 4 or 5 points. Is that not worth doing? That's why we have in the seminar. This is true of all condensing boilers. You've got to learn to think a little bit different, and this is what we want to drive the point home to you. Now, if we look at the condensing boiler, there's a couple of other issues we need to look at as we go. Let's just make sure we got them now straight. First of all, here's a little simple schematic of a condensing boiler. We got cold water coming in and hot water going out. That's what we wanted. But we're also going to pipe the air to it. We're going to have a fan assisted combustion. We're going to bring in outside air, and we're going to exhaust the outside air. It's going to be a Category 4 venting. A lot of the venting systems come from the particular boiler manufacturer that are rated Category 4. So go to your boiler vendor, get their recommendation on venting, and go with what they suggest you do. In addition to that, at the very bottom down here, we obviously got gas going into it. But at the bottom, we got this condensate tank. We got condensate coming out. And that condensate will be acidic, and we have to deal with it. So my message is, the addition thing is you got to make sure you got the right vent, and you got to make sure you deal with that condensate that's coming out of the bottom of the boiler. Have a great day. Thank you very much.